Okay, so we're going to do an example, but before I go into the example, let me just make one thing clear about Fermat's theorem. What Fermat's theorem doesn't state, or doesn't say, or imply, is that there will always be an extrema, a local extrema at a critical point. Okay? What Fermat's theorem is saying is that if there is an extreme value, it will happen at a critical point. Okay? Not saying it always will, but what Fermat's theorem is saying, hey, the critical points are the candidates that you can test to see if there is an extreme point. So if there is an extreme point, it's going to happen at a critical point. It's not saying that every critical point will bear fruit and say, hey, there's a extrema here. For example, if I look at the function f of x equal to x cubed, right, on the interval from negative infinity to positive infinity, then I know that there's a critical point at x equals 0, right? Because if you take the derivative of x cubed, you get 3x squared, okay? And so x equal to 0 will give you 0. So we know that there's a critical point at x equals 0. But we also know that x cubed is increasing on the entire domain. So that means that there are no extreme local extrema anywhere in the domain of the function. So again, the critical points, the reason why we want to look at the critical points is if we find the critical points, those are going to be the places where we're going to want to test, because it's going to be at those places that if there is a critical point, or excuse me, if there is an extreme value, that's where it's going to occur at one of those points or more of those points, but not necessarily at all of the points. Okay? So with that being said, let's jump in and do some examples. And so all we want to do is find the critical points for these functions. So let's jump right in. So here I'm going to find f prime of x. So f prime of x is going to be x squared minus 5x plus 4. And now we want to set this equal to 0, right? And so it's quadratic. So this is going to factor into what? 1 and 4. Right? So this is going to equal x minus 4 and x minus 1 equal to 0. So that means we have critical points at x equals 4 and 1. Okay? And that's it. Those are the only critical points we have. Okay, now, what about the next one? Here, we're going to use the chain rule. So f prime of x is equal to what? Well, we're going to take the derivative of the outside, which is going to give us 3 times x squared minus 1 squared, okay, times the derivative of the inside, which is 2x. And so that's going to give us 6x times x squared minus 1 squared. Now, where are the critical values here? Or critical points, critical values, critical points. Well, this is the difference of two squares. So this can be factored more, and it's going to be 6x times x minus 1 times x plus 1 quantity squared. So now this is going to equal 0 at which points? Well, when x equals 0 or when x equals 1 and negative 1. Now, there are no values of x, so for a and b, there are no values of x where it's undefined, right? So polynomials are defined everywhere, right? So again, this is defined everywhere. So there are no critical values where the the derivative is undefined, okay? Now, what about C? Let's do C then. Okay, C is going to involve the quotient rule. Okay, so we have f prime of C, and so the derivative of this thing is going to be 1 plus x squared times 4 minus 4x times 2x over 1 plus x squared quantity squared. Okay, so again, all I did was use the quotient rule. So now I'm going to simplify this, and I get what? I get 4 plus 4x squared minus 8x squared over 1 plus x squared quantity squared. Okay, now I could further simplify this because I've got a negative here, so this is going to give me what? Oh, well, I'm going to factor out the 4, so this is actually going to give me 4 times what? I'm going to get 1 minus x squared divided by 1 plus x squared. Okay, so now, first things first. Well, oh, wait a minute, we can go one more. Because this is the difference of two squares again. And so, actually, let me take out a negative. Let me take out a negative 4. So if I factor out a negative 4, this is going to then switch this to x squared minus 1, okay? And then I can do negative 4 times x plus 1 times x minus 1 over, again, 1 plus x squared quantity squared. Oops. Okay. So now, when is this equal to 0? We set this equal to 0. What do we get? We get x is equal to what? This is going to be equal to 0 when x is 1 and negative 1. But, what about undefined? Is this ever going to be undefined? So we look at the denominator for that, okay? So this rational expression will be undefined if the bottom is 0. Can the bottom ever be 0? No, because we have an x squared here. So whether x is negative or positive, it's always going to be positive, so we'll never get a 0 in the denominator. So those are the only values. So those are the only critical values. So that's it. That's how you look for critical values. You're going to find the derivative function. You set the derivative function equal to 0. And then you also look for places or values of x that make the derivative undefined. Those are going to be your critical values. Okay, that's it. Have a great day.